All right, hello class. Here I am going to be talking about gains from trade. So continuing on from today's lecture, we're going over the example which was a little bit confusing before, but I decided to present it a little bit differently so that it's easier to understand. So before we get started on the process of gains from trade, there are two types of advantages that we need to consider. So generally, what gains from trade basically specifies is that when you have two different producers producing a set of goods, when you trade based on specialization. So specialization basically means that if you have one trader who's good at making one good and the other who's good at making the other one, when they trade, they are better off from trading than if they were just to produce on their own. So as I go through the example of how numerically this makes sense, you'll see what I mean by this principle. So going on to the advantages, when we look in terms of producers, there are two major advantages that one producer or each producer can possess. So the first advantage that I want to go over is called absolute advantage. So what absolute advantage basically talks about is that it states that if a producer can produce more of a good given less inputs than relative to the other person, then they have that absolute advantage. So generally, when you're looking in terms of absolute advantage between two producers and two separate goods, you typically compare outputs. So you're looking at the output of the good and seeing simply who can make more. Okay? Now, on the other hand, comparative advantage takes a more different approach. So in comparative advantage, we're now looking at comparing opportunity cost. So simply what this means is that if we have a producer producing one good, we're seeing how much they're giving up of the other good to produce that good. So for example, if you're looking between apples and oranges, you calculate the opportunity costs for apples by seeing how many oranges he has to give up in order to produce, apples. So that is opportunity costs. Now, going over a specific example as we went over in class, I'm restructuring this a little bit differently. So in class, we talked about the minutes it takes to produce one good, but it was a little bit confusing to sort of understand the intuition behind that. So in terms of just, it was a little bit confusing and kind of categorizing everything together. So instead, I'm going to incorporate both producers on the same graph. So looking into terms of this, suppose we have two producers. We have Liz, and then we have Joe. So two producers over here. Now, and we also are assumed to have two goods. So let's assume that we have smoothies and salads. In future reference, when I structure my tests and exams and homework, I'll structure it in a way such as this. Okay, so now we have two producers and two goods. Now let's suppose in 1 hour, we have Liz, who could produce either 30 smoothies or 30 salads. Now, this doesn't necessarily mean that she can produce both 30 smoothies and 30 salads at the same time. It's more of either she produces 30 smoothies and 0 salads, or 0 smoothies and 30 salads. So it's more just producing, given her time available, this is the maximum she's able to produce. Okay? Now, given Joe's production possibility frontier, or given his values on the other hand, he can either produce 6 smoothies or 30 salads. So as we see over here, immediately we can see how to calculate the absolute advantage. So first and foremost, when we're looking in terms of absolute advantage, as I mentioned before, we're looking at calculating with respect to output, or comparing with respect to output. So it's very simple and straightforward to see who has the absolute advantage. So first of all, if we're looking in terms of smoothies, who has the absolute advantage in smoothies? Liz or Joe? Liz makes 30, Joe makes 6. So obviously the answer is Liz has the absolute advantage. In terms of salads, now who has the absolute advantage in making salads? They're 30-30. They're both exactly the same, so therefore they both have the absolute advantage. Okay? So generally over here, it's, like I said before, it's straightforward to calculate because you're just simply only comparing the outputs. Now moving on, we also have comparing the comparative advantage. So now we're strictly looking at comparative advantage. So this is where a little bit more work is required to kind of calculate the opportunity costs. Okay. Now, moving on, we have the table from the last table, which is 30, 30, 6, 30. Okay? So we're going to calculate the comparative advantage, but separately for each producer. So the first producer that we're going to look at is Liz. So let's look at Liz down here. Now, we have Liz, and we have two different goods. So the first good we have is smoothies. So what is the comparative advantage with regards to smoothies for her? Well, as we saw last time, or our last picture, the values are as follows, 30 and 30. So how to calculate comparative advantage is simply rise over run, or the ratio I loved using is what you give up and what you get in return. Okay, so we see from here that in order for Liz to get 30 smoothies, she has to give up 30 salads. So simply, the ratio is just going to be 30 salads over 30 smoothies. And it makes sense because in order to get, so this is the give over what you get ratio. She wants to get smoothies. So if she's getting smoothies, that's on the bottom, she has to give up salads, which is on the top. 30-30, simply put, the ratio is 1 salad. So generally what this means is that in Liz's case, 1 salad is worth 1 smoothie because in order to get 1 more smoothie, she has to give up 1 salad. Now, to calculate the other perspective is quite simple. So simply, if you want to save yourself some time, you can take the reciprocal or flip the denominator and the numerator, and you can get your answer. So in this case, if you want salad, you have to give up 30 smoothies for 30 salads. You're getting this is the ratio to get per salad. Like if you want per salad, how many smoothies you have to give up? And the answer is just 1 smoothie. And it's easy because the reciprocal, in this case, the reciprocal of 1 is 1. So it's just 1, 1. Okay? So you have Liz, who has 1 salad and 1 smoothie as their opportunity cost. Now, let's move on to Joe. So Joe, in this circumstance, as we recall from the last graph, or the last picture, so Liz was 30-30, Joe's is 6 and 30. So he can make either 6 smoothies or 30 salads. So let's calculate his value for smoothies. As we recall, this is the same ratio, what we give up over what we get. Now, he can either get, so he can, has to give up salads in order to get smoothies. We know that the value over here from the last graph was 30 salads. He has to give up 30 salad in exchange for 6 smoothies. And this value over here, we just simply do the math, and as a result, his opportunity cost is 5 salads. So this basically means each smoothie, to get one more smoothie, he has to give up 5 salads. So one smoothie is worth 5 salads. Now, going into the measurements for salad, again, you take the reciprocal, and you can save yourself some work. But if you want to just do the math again, it's easy. So it's what you give over what you get. To get a salad, he has to give up smoothies. So smoothies will now be on top. So 6 smoothies. And then you have 30 salads. You do the math, and the answer is 1/5 of a smoothie, which is exactly the reciprocal. So you have all these measurements, and now you want to figure out who has the comparative advantage. So we do this by actually comparing the opportunity costs of each producer with each good. So, for instance, let's look in terms of, oh, I'm sorry, my cat's here. Jules, come on, sweetie. Okay, sorry. So, you stay there, okay? All right, so now going back, we are trying to calculate the opportunity costs. So let's look at the opportunity cost for smoothies. Liz has 1 salad as her opportunity cost. Joe has 5 salads. So we're looking at who has the lowest opportunity cost. In other words, who's giving up the least to produce 1 smoothie. And the answer is Liz. She only has to give up 1 salad, whereas Joe has to give up 5. Now, moving on to the smoothies, we're seeing how many smoothies does each person have to give up to produce 1 salad? The answer is Liz only has to give up 1 smoothie, but Joe, on the other hand, only has to give up 1/5 of a smoothie. So he has much less opportunity cost with respect than Liz does. So if we're looking at who has the comparative advantage, going back to kind of comparative advantage, we find that in terms of smoothies, since Liz has only an opportunity cost of 1 salad, the answer is Liz has the comparative advantage in smoothies. Whereas in salads, it's Joe. So, as we do more examples in class, you're going to see a theme. But the theme in this is that when it comes to comparative advantage, mathematically, it's impossible for someone to have the comparative advantage in both goods. No matter how you calculate it, one person will always have the comparative advantage in one good, and one will always have the comparative advantage in another. And this establishes the theory that there are gains from trade, because no matter who you're trading with, there's always someone that has one advantage and someone who has another comparative advantage. One comparative advantage and someone has the other comparative advantage. It's never the case where one person has the comparative advantage in both goods. Now, looking back in terms of absolute advantage, it is possible that someone could have the absolute advantage in both goods. I could switch this up and put Liz can make 31 salads or something. And so she would have the absolute advantage in both goods. So that is absolutely possible for absolute advantage. But comparative advantage, it's one in the other. Okay, so now we calculated our values. Now, moving on, we can see kind of how this looks on the production possibility frontier. So let's work with Liz's first. Liz can make, let's see, this is 30, 30, and this is salad, and then maybe smoothie, yeah. So there's 2 goods. Now, her production possibility frontier is generally going to look something like this. Now, being in the middle, remember, this is not completely drawn to scale. We can say that around the middle point, if she decides to equally devote time to both goods, it's around 15 and 15. But the endpoints are 30 and 30. So this is our production possibility frontier for Liz. Now let's look in terms of Joe. So drawing something very similar. We have salad and smoothies. Now, given from our first picture, Joe can produce six smoothies or 30 salads. So let's make those measurements here. So that's 6. And then we have something way at the end, which is 30. So we have this kind of weird looking production possibility curve. Now, suppose he wants to kind of devote kind of similar resources to make both of them. So if he wants to make strictly 5 smoothies, then how many salads will he make in return? Well, look in terms of the opportunity cost. We see from Joe that 1 smoothie is worth 5 salads. So therefore, if he's strictly focusing on making 5 smoothies, then 5 smoothies is worth 25 salads. And if he's so in the sense where if he's only more focused on making 5 smoothies, so we have this measurement 5, what's that going to come out to? If he makes 5 smoothies, he only can make 5 salads because he subtracted 1 smoothie in a sense, and that's only worth 5 salads. So that's just this measurement over here. If you guys are still unclear on how I got to this is just in the concept of opportunity cost. So one more time, it's just saying that, 1 smoothie is worth 5 salads. So if he's not making one smoothie and like subtracting 1 smoothie from his production, that's the 5 salads here. That's what it means. And then for Liz, it's a little bit more straightforward because 1 salad is worth 1 smoothie. So therefore, 15 smoothies is the equivalent of 15 salads. Whereas here, 5 smoothies over here is equivalent to 25 salads, which was subtracted from this amount, which gives us just 5. Okay, so we have our PPFs over here. Now, we're going to compare 2 kind of cases over here. So suppose that we have a case where they don't trade. They are just only producing on their own. I apologize, my cat's making some noise in the background. So we have, in this case, Liz and Joe. And then we have the smoothies and salads. So we have this case before trade. Now, in this case, this is what would happen if they only produced by themselves without, any help. So let's look at this graph. Liz can produce 15 and 15. So this is 15 and 15. Joe can produce 5 and 5. So this is 5 and 5. Now, this is before trade. So this is the exact amount they would be producing on their own. So this is not either producing 15 or 15 in this case. This is actually them saying, okay, I'm going to produce 15 smoothies and 15 salads. Whereas in this case, this was saying what they can possibly produce, either 30 smoothies or 30 salads. So that's a main distinction I want you guys to make. Okay. So now going after trade, well, this is actually, in this case, it's after trade, when they start specializing. Actually, yes, let me correct that amount. This is more in the case of specialization. So yeah, let's keep this a separate step. Specialization. So we're now moving into the case of specialization. Now in specialization, this basically means that they're only going to produce the good that they have a comparative advantage in. So redrawing the table, smoothies and salads. Yeah, okay. So they're only going to be producing what they have the comparative advantage in. Now, reviewing from our second page, we see that Liz has the comparative advantage in making smoothies, while Joe has the comparative advantage of making salads. So that means that Joe should only focus on making salads, and Liz should only focus on making smoothies. Now, looking in terms of the production possibility frontiers, we see that 30 is the most that Liz can make if she solely focuses on producing smoothies. So we're going to write this amount down here, that Liz is producing 30 smoothies but 0 salads. She's not even thinking about salads. Now Joe, on the other hand, can produce either 30 salads or 6 smoothies. So in this case, Joe has the comparative advantage in producing salads, so he's going to devote all his resources and time producing salads, so that's 30, but he's producing 0 smoothies. So now introducing the final step into kind of looking to how this all ties in together is we're looking at after trade. And as a result from after trade, we're going to see the whole point of gains from trade from here. So we're looking at Liz and Joe, and then we're going to look at, okay, we have smoothies and salads. So from the gains from trade over here, well, originally, we're just going to compare before trade and then after trade. So as we call before trade, these were the appropriate measurements that we had. 15, 5, 15, 5. So Liz was 15, 15, Joe was 5, 5. That was our previous measurement. But what if we were to gain from trade? So gain from trade in this sense is that we have that Liz can produce 30 smoothies and 30 salads. So let's say that in this case, Liz can trade the amount of smoothies that she makes. So in this case, what if she takes 30 of her smoothies, she has 30 smoothies, what if she gives some of them to Joe? Now the question is, how much does she give to Joe? So what she gives to Joe generally is that what if she gives about 10 of them? So she gives 10 smoothies. So I'm going to write down here. Liz gives 10 smoothies to Joe. So Joe is going to start gaining the smoothies. Now, and in terms of Joe, if he makes 30 salads, what if in exchange, Joe gives 20 salads to Liz? So what is that case? So Liz gives 10 smoothies to Joe. So this converts to 20 because she had 30 smoothies. She gives 10 of them to Joe, so she lost 10. But this is going to 20. Now, for salads, Liz originally started at 0 salads, but she's receiving salads from Joe, which is plus 20. So this is now going to 20. Joe, on the other hand, he is not making any smoothies. So he started at 0, but Liz gives 10 smoothies to Joe. So Liz gave 10 smoothies, so he's actually earning 10. So this turns to 10. And Joe had 30 salads, but he is giving away 20 of them. So he's left with 10, so this goes to 10. So as you can see over here, this is the interesting part. You can see that under trading, both of them profit, where they all gained 5 each, and each good for each person. Because if you look at the outcomes, this is the outcome before trading at 15, and this is the one afterwards. So they're actually gaining 5 from each one. So this is the concept of gains from trade. When you trade based on comparative advantage, there's always a benefit in terms of what you're ended up later on or at the end of the day. And graphing this in terms of the production possibility frontier, you have Liz over here. Let's see. You have the smoothies and you have the salads. Okay. 30, 30. So this was her production beforehand. She can, by herself, she made 15, 15. But under the new trade, she's actually now making, in this case, 20. You know, we have over here. This is by trading, where she has 20 and 20. So, and then over here you have Joe, who originally had a production possibility frontier. In this case, oh sorry, hold on. He had a production possibility frontier. In this case, hold on, let me rephrase that. That was my mistake. Sorry, my cat's here again. Excuse me, Tracy. My production possibility frontier, and here for Joe. There you go. It was 30 and 6. We have smoothies and salads. So in this case, when you have this over here, his old outcome was that he only could have 5 and 5. So let's draw that. He had like 5 and 5. Again, not completely drawn to scale, absolutely not. This is just a rough sketch. But now under the new equilibrium, he can now get 10 to 10. And this is from trading. So my final point also is that when you look in terms of the two outcomes, they are both outside the production possibility frontier. So remember in class we talked about economic growth. Economic growth allows you to go beyond your production possibility frontier by improving on technology and labor and land and such. But gains from trade leads to growth. That yes, when you do trade, you are also growing and you can produce outside your production possibility frontier. So that's the main takeaway from gains in trade and why it's better to trade based on specialization. All right, thank you very much, everyone. I hope this video helped you, and I'll see you on class.